ambitiously, plan meticulously, and work diligently, definitely you will succeed in your life. Today we are going to deal with the new concept, simple pendulum. What is simple pendulum? Heavy sphere or metal core suspended by means of inextensible wireless string from the rigid support, that is called a simple pendulum. What is simple pendulum? Heavy metal bob suspended from rigid support. This is rigid support. By means of this inextensible wireless string, then it is called a simple pendulum. अगर मेटल बॉब को हम रिजिड सपोर्ट से इनएक्सटेंसिबल वर्टलेस स्ट्रिंग से सस्पेंड करते हैं तो उसे हम सिंपल पेंडुलम कहते हैं. This simple pendulum, this OA position, this position, middle position of the figure, that is called as equilibrium position. That is called as mean position. This is OA is the mean position. This pendulum is displaced to a small angle theta. This pendulum will start to and fro motion about the mean position. मैंने इस पेंडुलम को थीटा एंगल से डिस्प्लेस किया है, तो ये पेंडुलम मेन पोजीशन के बोथ साइड्स टू एंड फ्रो मोशन करेगा, आगे पीछे करेगा. जब ये पेंडुलम बी पॉइंट पर आकर रुकता है तो उस पर दो टाइप्स के फोर्स एक्ट होने लगते हैं. When the pendulum is at point B, what happens? Two types of the forces will act on the pendulum. Which are those? Tension in the string and the second is weight of the bob. जब यह पेंडुलम बी पॉइंट पर आकर रुकता है तो उस पर दो टाइप के फोर्स एक्ट होने लगते हैं. एक टेंशन जो ऊपर की तरफ जा रहा है और जो बॉब का वेट डाउनवर्ड की तरफ खींच रहा है, mg. This mg can resolve into two components. This weight of the bob can be resolved into how many components? Two components. Which are those? Mg sin theta and mg cos theta. These are the two components. Mg can be resolved into how many components? Two components. Which are those? Mg sin theta and mg cos theta. Mg sin theta which is perpendicular to the string. Here this component mg sin theta is acting as a restoring force. ये जो कंपोनेंट है mg sin theta वो रिस्टोरिंग फोर्स का रोल अदा करता है. रिस्टोरिंग फोर्स किसे कहते हैं? जो फोर्स बॉडी को मीन पोजीशन की तरफ खींचता है, उस फोर्स को हम रिस्टोरिंग फोर्स कहते हैं. और उस फोर्स का मैग्नीट्यूड हम mg sin थीटा लिखते हैं. उस फोर्स को हम F इज इक्वल टू रिस्टोरिंग फोर्स को ऐसे लिख सकते हैं माइनस mg sin थीटा. माइनस साइन इसीलिए आया हुआ है, फोर्स और ये डिस्प्लेसमेंट दोनों अपोजिट साइड है. ये डिस्प्लेसमेंट एंगुलर ऐसा और ये फोर्स पीछे की तरफ खींच रहा है, इसीलिए माइनस साइन यहां लिया गया है. F इज इक्वल टू माइनस mg sin थीटा. लेकिन ये जो एंगल थीटा है वेरी वेरी स्मॉल है, इसीलिए इस साइन थीटा के जगह हम थीटा लिख सकते हैं. I can write theta instead of sin theta. I will write theta instead of sin theta. I should write theta instead of sin theta. I have right to write F is equal to minus mg theta. The above equation becomes F is equal to minus mg theta. Instead of sin theta, what I have taken here? Theta. Why I have taken the theta? Theta is very very small. According to Newton's second law of motion, instead of force, I can write ma mass into acceleration. इस force के जगह हम mass into acceleration लिख सकते हैं. minus mg theta as it is. AMM get lost. A is equal to minus z theta. A is equal to minus z theta. और फ्रॉम द ज्योमेट्री ऑफ द फिगर थीटा को हम कैसा लिख सकते हैं, आर्क अपॉन रेडियस, ये आर्क है और ये रेडियस एल, आर्क अपॉन रेडियस x अपॉन एल. थीटा कैन बी रिटन एज x अपॉन एल. So instead of theta I can write acceleration equal minus z x by l, minus z x by l. In magnitude, how it is to be written, minus side should be ignored. A is equal to z by l into x. So this equation I can modify A upon x is equal to z by l. What is our object? To find out the period of the simple pendulum. How to find the period of pendulum? 2 pi is equal to t is equal to 2 pi upon omega. Instead of omega, I can write under root a by x. How it is happened? See, a is equal to omega square x. We have seen this equation. So a by x is equal to omega square. So omega is equal to under root a by x. So instead of omega, I can write under root a by x. And the period of simple pendulum, the formula is t is equal to 2 pi by omega. So t is equal to 2 pi under root. Instead of omega, I can write under root a by x. This is the acceleration per unit displacement. Or instead of this acceleration per unit displacement, a by x, instead of a by x, I can write z by l. I can write t is equal to 2 pi under root z by l, which is equal to 2 pi under root l by z. This is the object what we needed to have. The period of simple pendulum is t is equal to 2 pi under root l by z. What is simple pendulum? Consider a simple pendulum of mass small m. Consider a pendulum of mass small m. This pendulum is suspended from the rigid support. OA is the equilibrium position of the pendulum. When the pendulum is displaced through an angle theta, pendulum starts to and fro motion about mean position. When the pendulum is at point B, restoring force will act on the pendulum, and that restoring force F is equal to minus mg sin theta. Theta is very, very small. Therefore, the above equation can be written as F is equal to minus mg theta. According to Newton's second law of motion, I can write instead of F, m into A is equal to minus mg theta. M get lost. A is equal to minus z theta. From the geometry of the figure, I can write theta is equal to arc divided by radius. Arc x. This is x, this is the arc, divided by radius L. A is equal to minus z into x by L. अगर हमें इसे मैग्नीट्यूड में लिखना है तो हम लिख सकते माइनस साइन ओमिट कर सकते हैं. A is equal to z by L into x. In magnitude A by x is equal to z by L. अभी हमें यहाँ देखना है ये इक्वेशन कैसे बन रहा है. आगे की तरफ देखिए. Acceleration is equal to, we know that, हमें मालूम है, we know that acceleration is equal to omega square x. Omega square as it is, x can be transferred to this side, a by x, taking square root on both sides. Omega is equal to under root a by x. हमें पीरियड निकालना है सिंपल पेंडुलम का. पीरियड का फॉर्मूला हमें पता है, t is equal to 2 pi by omega. t is equal to 2 pi under root 2 pi by omega. ओमेगा की जगह हम ये लिख सकते हैं this equation as follows. T is equal to 2 pi under root z by L. 2 pi under root L by z. This is the period of simple pendulum. From this expression, I can conclude that period of simple pendulum depends upon two factors: length of the pendulum, number 2, acceleration due to gravity, but it is independent upon mass of the bob. Let's stop here.